Good morning children. Today we have to learn the new chapter, chapter 7, Permutations and Combinations. The first part is multiplication principle or the fundamental principle of counting. So let us consider some examples. The first one, suppose a boy has 3 shirts and 2 pants. In how many different ways can he dress up with? So 3 different shirts, let us denote S1, S2 and S3. 3 shirts and 2 pants. So let P1 and P2. Then in how many different ways can he dress up with? So we have to take combination. This S1 with P1, that is one possibility. S1 P1, first shirt with first pant. Now I can write S1 P2, that is another case. Then S2 P1, S2 P1 and S2 P2. Now we have one more shirt, so S3 P1 and S3 P2. So how many different cases are there? 1, 2, 3, 4, 5, 6 possibilities. Okay. Now consider another example. Suppose a girl has 2 bags and 3 water bottles and 2 umbrellas. So bag, water bottle and umbrella. In how many ways can she carry these items to school? So we can denote 2 bags as B1 and B2. Okay, and water bottle W1, W2, W3. Then umbrella U1 and U2. Okay, U1, U2. Now we have to write all the possibilities. Okay, so bag 1 with W1, that is bag 1, water bottle, first water bottle and umbrella, first umbrella. So B1, W1, U1. This is one possibility. Then I can write B1, so this one, W1, then U2. Okay, then B1 with W, we have 3 water bottles. So W2 U1, then B1 W2 U2, then B1 W3 U1 and B1 W3 U2. Okay, so here the first one is B1. In all the 6 cases it is B1. Now we have one more bag, that is B2. So B2 with B2 W1 U1, then B2 W1 U2, then B2 W2 U1, B2 W2 U2, then B2 W3 U1 and B2 W3 U2. So total 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 possibilities. And here we have 6 possibilities. So if it is some questions will come, then it is very difficult to list all the possibilities, isn't it? If more items are there, then it will take lot of time to list all the elements. So we have to use the multiplication principle or fundamental principle of counting. So what is that principle? The principle says that if an event occur in m different ways, suppose the first event occur in m different ways, following which another event that occur in n different ways, then the total number of occurrence of events in the given order is m into n. Okay, so in the first example, 3 shirts and 2 pants. So the first event, that is shirt, that is occur in 3 different ways, and following which the next event, that is pants, that is 2. Okay. So the total number of occurrence of events is 3 into 2. That's equal to 6. There are 6 possibilities. On the second one, that is there we have 2 bags, 3 water bottles and 2 umbrellas. So if an event occur in m different ways, following which another event occur in n different ways, then the next event, suppose it occur in p different ways, then the total number of occurrence of events, that is m into n into p. So in the second example it is 2 into 3 into 2. 2 3s are 6, 6 into 2, 12. So we can use this multiplication principle. It's very important. In competitive exam and all, this type of questions will come. So you have to remember this result. This you need in future also, not only this 11th and 12th. Okay. So the principle says that if an event occur in m different ways, following which another event occur in n different ways, then the total number of occurrence of events, that is m into n, in the given order. So we can do problems. Find the number of 4-letter words with or without meaning which can be formed out of the letters of the word rose, where the repetition of the letters is not allowed. So here one word is given, rose, R-O-S-E. Then the number of 4-letter words. Using these 4 letters, we have 4 letters R, O, S and E. 4 letters are there. Using these 4 letters, how many different words we can form, with or without meaning, and repetition is not allowed. We can't use R 2 times or S 3 times, not like that. Use only once. Use all the 4 letters and form a 4-letter word. So how many 4-letter words we can form? So if we write, so look, the first word I can write as R-O-S-E. Then we can change the place of these letters. I can write like this, or E-O-S. So total how many letters, total how many words are there? So just check here. I wrote here all the 4-letter combination, R-O-S-E. Then in these 6 words, first letter is R. R-O-S-E, then R-O-E-S, then R-S-O-E, then E-O, then R-E-O-S, here S-O. Then change the place of R. R is, the first letter is O. Then the same way you can change the 3 letters. The next combinations, S is in the first place, the last E is in the first place. So how many letters, how many words are there? Using these 4 letters, here 6 words, 6, 6, 6. That is 6 into 4, total 24 words we can form. Okay, using these 4 letters. But here also, writing all these and checking how many words is possible, it's very difficult. So here also we use the multiplication principle. So how we use that principle here? We have to form a 4-letter word, isn't it? A 4-letter word we have to form using these 4 letters. So first look the first place. This first place can be filled in how many different ways? I can write the first place, in the first place either R or O or S or E. There are 4 possibilities. So this first place can be filled in 4 different ways. Okay. So this can be filled in any of these 4 letters, and 4 ways are possible. So here just you can write 4. This 4 means 4 ways. There are 4 ways. This can be, the first place can be filled in 4 different ways, since we have 4 different letters, isn't it? Now moving to the next place. So here 4 ways are possible, but we write only one letter here, either R or S or O or E. Then when we move to the second place, now how many letters are there? Now only 3 letters, already 1 letter in the first place. Okay, so when we move to the second place, here only 3 letters. Okay, suppose in the first place I wrote R. Now in the next 3 place, when we go to this place, we have only 3 letters, O, S, E. So this place we can fill in by 3 different ways, using any of the remaining 3 letters. Already 1 letter in the first place, that we can't take, since the letters not, repetition is not allowed, that's why. If repetition is allowed, this place also we can fill it in by 4 different ways. Okay, so this place can be filled in 3 different ways. Now move to the next place. So move to the next place means 1 letter is here, either O or S or E, if R is in the first place. So suppose here it is S. So now when we move to the next place, how many letters in our hand? Only 2 letters. So this third place can be filled in 2 different ways. Okay, then when we move to the next place, how many letters? Only 1 letter in our hand. Okay, now after this, what we have to do? Using multiplication principle, you have to multiply. Okay, so once again we have 4 letters, R, O, S, E. Using these 4 letters, how many words we can form? Repetition is not allowed, that is the condition given in the question. Okay, so 4 places are there. The first place we can filled in by 4 different ways. Why 4 different ways? Since there are 4 different letters. Okay, now after that, the second place. In the second place we have only 3 letters, since 1 letter is in the first place, that we can't take, since repetition is not allowed. So in the second place we can use any of the 3 letters. Then the next place, that is first place, second place, third place. In the third place, that we can fill it in by 2 different ways, since we have only 2 letters. Then in the last place only 1 letter. So what is the total number of words? 4 into 3 into 2 into 1. 4 3s are 12, 12 2s are 24. That is same as this one. But this listing or writing all the possibilities, it's very difficult. That's why we use the multiplication principle. Okay, and here repetition is not allowed. That's why 4 into 3 into 2 into 1. If repetition is allowed, then how we write? If repetition is allowed, the first place we can fill in by 4 different ways. The next place, in the next place also, if in the first place R, in the next place also we can use R, since we can use the digits can be, letters can be repeated. So this place also we can fill in by 4 different ways. The third place also in 4 different ways. Last place also 4 different ways. So if repetition is allowed, 4 into 4 into 4 into 4. If repetition is not allowed, then 4 into 3 into 2 into 1. Okay. Now look this question. How many 2-digit even numbers can be formed from the digits 1, 2, 3, 4, 5 if the digits can be repeated? How many 2-digit even numbers? 2-digit, only 2 digits are there, and the numbers are even numbers. What is the condition for even number? The unit place or ones place digit must be an even number. that is either 2, 4, 6, 8 or 0. Here we have only these digits are given 1, 2, 3, 4, 5. Which are even in these 5, 1 to 5 numbers? 2 and 4 are even numbers. Okay. So, even numbers only 2, isn't it? Number of okay. So, how many 2 digit? Ones place and tens place, or units place and tens place. So, this unit place we can fill in how many different ways? We can use either 2 or 4. We can't use 1 since we need an even number. If the last digit is 1, it is not an even number. So, the last place or unit place can be filled in. Unit place can be filled in how many different ways? 2 different ways. By 2 different ways. By 2 different ways by using any of the 2 digits. Any of the 2 digits, 2 or which is the other digits? 2 or 4. Okay. So, this can be filled in 2 different ways. Now, what about tens place? Digits can be repeated. Okay. So, whatever here in the last place, if it is 4, you can again use 4 since digits can be repeated. So, in the tens place, we can use any of these 5 digits. Any of these 5 digits. So, this tens place can be filled in how many ways? 5 different ways. Tens place can be filled in by 5 ways. Okay. So, what is the total number of 2 digit numbers? The first place in 5 ways, second place in 2 ways. So, 5 into 2, 10. So, the number of 2 digit even numbers is equal to 5 into 2, that is equal to 10. Understood? Here 1, 2, 3, 4, 5. 5 digits are given. We have to form a 2 digit even number. So, you have to fill first a unit place or ones place, then tens place. So, ones place or unit place that can be filled in 2 different ways since among the given digits only 2 even numbers, 2 and 4. Now, moving to the tens place, since digits can be repeated, that is the condition given in the question, we can use any of the 5 digits in the first place. So, first place can be filled in by 5 different ways. Don't think this 5 is the digit 5 and this 2 is the digit 2, not like that. 5 different ways and 2 different ways. So, total number of 2 digit even numbers is 5 into 2, that is equal to 10. The next one, how many 3 digit numbers can be formed from the digits 1, 2, 3, 4 and 5, assuming that repetition of the digits allowed, and second case repetition is not allowed. So, here 3 digit numbers. So, 3 places are there. 3 digit numbers, not even or odd, 3 digit any number. How many digits are there? Total number of digits. Digits given, 5 digits are given, isn't it? 1, 2, 3, 4, 5. And the first case is repetition is allowed. So, we can either from this side or this side. No restriction is here. So, anyway we move from units, tens and hundreds. So, the unit place can be filled in how many different ways? Repetition is allowed. We have 5 digits, So we can fill this place in 5 different ways. What about tens place? There also we can use 5 digits or 5 different ways we can fill that place. Now hundredths place, that also in 5 different ways. So 5 into 5 into 5, that's equal to 125. The second one, repetition is not allowed. So repetition is not allowed. That means in the unit place we can use any of the 5 digits. So unit place can be filled in 5 different ways. Okay. Then when we move to the next place, that is tens place, how many digits in our hand? Only 4 digits, since 1 digit is here. I can write either 1 or 2 or 3 or 4 or 5 in this one's place. Then only we move to the next place. But this can be filled in. This 5 is not this digit 5. Okay. This 5 means number of ways. Number of ways the unit place can be filled in using these digits is 5. Now when we move to the next place, we have only 4 digits since repetition is not allowed. So if I write 1 here, we can't use again 1 in the next place. Okay. So here only 4 digits. Now the next place, 3 digits. So 3 into 4 into 5. What is it? 16. I hope you understood. So if repetition is allowed, that you have to multiply 5 into here, 5 into 5 into 5. But if it is not allowed, you have to subtract 1, 5 into 4 into 3, like that you have to go. Okay. The next is how many 3-digit even numbers can be formed from the digits 1, 2, 3, 4, 5, 6 if the digits can be repeated. 3-digit even number. So here unit place, tens place, hundreds place. Unit place we can fill in by how many ways? How many even digits are here? 2, 4 and 6. Okay. So this unit place we can fill in 3 different ways. Now what about this tens place? Digits can be repeated. Okay. Digits can be repeated means you can use all the 6 digits here. So this can be filled in 6 different ways. Also the hundreds place in 6 different ways. So total number of 3-digit even numbers 6 into 6 into 3, that's equal to 36 into 3, that is 108. Okay. So you have to write, you have to explain. Okay. So when you write the answer, you have to write the unit place can be filled in 3 different ways by any of the 3 digits 2, 4 or 6. Then tens place we can fill in by 6 digits. Okay, hundreds place also we can fill in 6 place since the digits can be repeated. Then the total number of 3-digit even numbers is equal to 6 into 6 into 3, that's equal to 108. How many 5-digit telephone numbers can be constructed using the digits 0 to 9 if each number starts with 67 and no digit appears more than once? How many 5-digit telephone numbers? 5 digits. Using the digits 0 to 9. 0 to 9, how many digits are there? 10 digits are there. In that 10 digits, the number starts with 67. That is first place 6, second place 7. This we can't change. The all telephone number starts with the 67. So we have to fill only these 3 places. And also no digit appears more than once. So first place 6, second place 7. That 2 digit we can't take. Okay. So out of 10 digits, now we have only 8 digits. Clear this? So we have 8 digits and 3 places. No digit appears more than once, that's why only 8 digit. So this third place we can fill in how many different ways? We have 8 digits. So in 8 different ways I can fill this place. Then the next place, no digit appears more than once. So in 8 ways we can fill. Okay, 8 place we can fill means we have to write any one digit in this place. That digit you can't use in the next place. So when we move to the next place, how many digits in our hand? Only 7 digits. So in 7 different ways we can fill the next place. And the last place, how many ways? 6 only. Okay, so 8 into 7 into 6. The first place is fixed, it is 6. So only one way. This is filled in one way, this also filled in one way. So 1 into 1, no need of that. Just you multiply 8 into 7 into 6. What's it? 8 sevens are into 6. 336. 336. How many 4-letter code can be formed using first 10 letters of English alphabet if no letter can be repeated? How many 4-letter code? 4-letter code using the first 10 letters. That is A to J. 10 letters are there and we have to form a 4-letter code. And the condition is no letter can be repeated. So 10 letters are there and 4 places. So the first place you can start from this side or this side, no problem. But for numbers, if it is even and all, you have to start always from unit place. So the first place I can fill in by 10 different ways since 10 letters are there. But when we move to the next place, no letter can be repeated. So here only 9 letter, then 8 letter, then 7 letters. So 10 into 9 into 8 into 7. If repetition is allowed, then how we write? 10 into 10 into 10 into 10. Okay, now you multiply 90 into 8. 5040. So that much 4-letter codes are possible. And it's very difficult to list all the 4-letter code using these 10 letters, isn't it? More than 5,000. So using this multiplication principle, it is very easy. So what is multiplication principle? If an event occur in m different ways and another event occur in n different ways, then total number of occurrence of events in the given order is m into n.